What's going on, everyone? My name is Johnny Bandon, and I'm your CCNA instructor for this CCNA video series. In this video, we're going to go over the network components, and this is going to be all the hardware that you're going to find on the enterprise and that the CCNA exam objectives want you to know about. And it's important that we understand what the device is doing, what layer it operates in, before we start getting into configuration and different protocols and features that these devices do. So without further ado, let's get started. Okay, so the first thing we're going to touch on is actually just going over what the network and enterprise infrastructure is, okay? So network professionals will manage and maintain key network hardware in this, and in this course, we will focus on the network components that Cisco wants us to know about or wants us to learn about, okay? So there's a lot of infrastructure and hardware that professionals use all the time, right? In cybersecurity, we have SIEM or SIEM, some people say, intrusion detection systems. But for the CCNA, for a network administrator, we are just going to go over the network components and hardware that are important for you. So as you can see on here, using, again, guys, shout out to Canva that's helped me make all these slides. You can see all the different network components on here, right, with symbols that I got from Canva. So we have endpoints or a computer. We have our switch here, which looks like a multi-layer switch or a real beefy one. We have our wireless router or access point, another one here. We have servers. And of course, right here, we have our router. So these are going to be all the network components that we're going to go over in the next few slides, and a couple other ones like wireless LAN controllers. Okay, so the first thing we're going to go over is a switch. So what is a switch? So this is a networking device that forwards data packets, or otherwise known as frames when we're talking about switches. Let me get my pen working again. Frames locally within a LAN, okay? So a switch works in something we call layer 2. And in layer 2, we got frames, and we forward these frames based off MAC addresses. These MAC addresses are the 12-digit hexadecimal addresses that are burned in addresses onto your network interfaces, or your Ethernet ports, or whatever you want to call it, your interfaces, right? So every NIC, network interface card, or every Ethernet port on a switch is going to have a MAC address, okay? And it's a switch's job to forward all these different MAC addresses within a LAN. A switch does this by using what we call a CAM, or a MAC address table. CAM stands for content addressable memory. And think of this MAC address or this CAM table as honestly just a long spreadsheet of telling you which MAC addresses are tied to which ports. So if we have computer A here, computer B, in that MAC address table, we're going to say, hey, port 1 has computer A's MAC address. Port 10 has computer B's MAC address. So now when these two want to talk to each other, they're going to forward a frame, right? And in that destination frame, it's going to be computer B's MAC address. And that switch is going to receive that frame and say, hey, I know this MAC address. It belongs to port 10. I need to forward this frame there. So without a high-level overview of what a layer 2 switch is and what it does, it uses MAC addresses to forward frames across a LAN using the MAC address or the CAM table. High-level overview, 50,000-foot view of what a switch does. And of course, we always got to know they work in layer 2. Later on in our video series, we're going to dive deep into switching and switching concepts, and dive deep into actually the MAC address table and how a switch forwards frames or MAC address it doesn't know about, right? And then out of the box, remember, switches are always layer 2, but a switch can also be configured to run layer 3 protocols or IP addressing. So you can turn a switch into what we call a multi-layer switch, where it also performs routing, okay? So again, out of the box layer 2, but can be configured to run layer 3 protocols. And that will include like routing protocols and other features that are IP based. Okay, now let's move on to what a router is. So this is a networking device that's going to forward packets based off their internet protocol address. So a router is that one device that is responsible for data reaching its destination and coming back, right? So a router forwards based off layer 3 information out of the box, IP addressing. A router does this by building what we call a routing table. That's also kind of like a long spreadsheet of where you need to send IP addresses. So this routing table, again, this isn't exactly accurate, but it'll say, hey, if you want to talk to 10.0.0.0/8, you need to forward traffic out Ethernet 00. Okay? So that routing table is kind of the brain of the router. It's how the router makes forwarding decisions. And we build that routing table by exchanging all our known routes to all of our neighbors. So in a big autonomous system and domain, if we're using routing protocols, dynamic ones especially, all the routers should know about all the networks they know about. So again, out of the box, routers are layer 3 and will perform basic IP routing and forwarding functions. And then we have something called, I have this note here. If properly licensed, Cisco ISR devices can perform more than just IP routing. So what do we mean by that? Well, what is ISR, right? Because in tech, and really everybody, every company, every industry loves their acronyms, right? So ISR stands for Integrated Service Router. And the reason we talk about Cisco's ISR platforms and different series in the CCNA is because mainly a CCNA is working with these types of routers that you're going to see on an enterprise or a company's autonomous system or domain, right? Usually a CCNA isn't going straight to ISP networking where we'll go into big ASR platforms or even start going over Juniper, I know, routers and systems. The CCNA is more for the enterprise. And when you work in the enterprise, you're going to be working on a lot of ISR platforms. Where these Cisco ISR platforms do more than just routing. They can perform firewall functions. I don't know how much common this is nowadays, but they can also do telephony services. They can also do more advanced like IPsec-based stuff. And these ISRs can perform more than just simple IP routing, right? Especially if a small business, small, medium-sized business, doesn't want to pay for that dedicated firewall, doesn't want to pay for that call manager sitting on its domain, you can run all those services straight from that Cisco router, okay? So that's what that integrated service router means. So to recap on what is a router, it is a layer 3 device that builds a routing table to forward packets based off the IP address. All right, now let's get into what is a firewall. So this is a networking device that typically sits in line and at the edge of your network to filter packets coming in and out. So what a firewall is going to be a dedicated device that usually would sit kind of like this on your network, right? It'd have the connection to the ISP and then connected to your router when you have your LAN here. And you could also maybe have like a DMZ off here with servers connected to that firewall, right? Switch in between here. But what this firewall does is it's going to create zones, right? Inside and outside zones that are trusted and untrusted, essentially. And it's going to filter packets based off a number of different criteria. So a simple firewall or just a layer 3 and 4 firewall is going to filter based off IP addresses, ports, and protocols, right? And when we say filter, we mean deny or permit. You may also see in other vendors allow or deny, right? But essentially, these firewalls have long lists of what to do with traffic that it's inspecting, okay? And then we have different types of firewalls. We have stateless, stateful, application level, where it's actually going deep into the packet to do that inspection to filter based on an application. It could be so granular, right, to where we could allow Facebook in our network, but deny Facebook messaging all through that application level firewall. We have context-aware firewalls where it could be one piece of hardware, right, that's kind of doing unified threat management, where we're integrating data loss prevention. We're doing like EDR kind of detection and response, right? And then we can also still filter based off layer 3 and layer 4. And then we can even do context aware, where we put some AV capability on there, antivirus capability on our firewall, where we're actually looking at signature matches and hashes coming across our network to see, hey, this hash matches a virus or maybe potential malware. So a firewall in the simplest level, right, and probably at the CCNA level without me getting off the rails and going too deep, it's going to filter based off layer 3 and 4 protocols, right? So it's going to filter based off IP, address, source, and destination. And then also the ports and protocols, right? Port numbers, your transmission protocols, right? So TCP, UDP, ESP, maybe even some routing protocols. There's a lot of different options, right? But these firewalls, and then depending on the type, the licensing, and purpose, are going to do a number of different types of filtering, okay? And again, typically that firewall is going to sit on the outside of your network, but in line with the traffic flow, okay? So it can filter and inspect everything coming in and out. An access point. So a wireless access point is a piece of hardware that allows your Wi-Fi enabled devices to reach back to the network infrastructure, okay? Or the distributed infrastructure, as they like to call it in Wi-Fi terms, right? The distributed network. So in Cisco, we have different types of access points that we're going to learn about. So we have autonomous, lightweight, and cloud-based. These two being the most similar because they're going to be centrally controlled by some sort of server or what we call a controller, with a lightweight access points getting all their settings and their profile from what we call a WLC, a wireless LAN controller that's going to sit inside your enterprise. Then the cloud-based access points, same functions as a lightweight. They're going to get all their profiles and their settings and how they should respond and what Wi-Fi signal, all their everything, right? But it's going to be cloud-based. So it's going to be centrally controlled by some server out there in the internet that a human or a network administrator is controlling on a cloud-based dashboard. A huge example of this is Cisco Meraki, okay? And then we have autonomous, and this is on your home network, what everyone should have straight from the ISP, where that access point is doing more than just communicating with Wi-Fi enabled devices. It's actually doing routing, MAC filtering, maybe some firewall function, pretty much an all-in-one, right? It doesn't need to be controlled by some server or some cloud-based dashboard. It's autonomous. You set it up, and then it's doing everything for your network, right? Routing, firewall access, whatever the case may be, right? Again, all depends on what your environment is. In a medium to large size business, you're going to want lightweight or cloud-based access points because you're going to have lots of access points all over your office or your campus network. If you're a small business in a one-room office floor or in a shopping center, strip mall, maybe you just want autonomous. Maybe you just want that one wireless access point that does everything for your business, okay? Really just depends. And this autonomous does have some scalability. You can do mesh networks with autonomous access points that are going to share and let devices connect to the other access points when they're moving about. But that's as far as it scales. Maybe 1 or 2 or 3 access points in a mesh. if you want scalability, you're going to want these two options, lightweight or cloud-based. And again, later on in the series, we'll go deeper into wireless and into these types of access points. And then we have that wireless LAN controller, like I was saying. So this is a networking device that has central control and management over wireless access points, right? So again, a wireless access point has to be set up in lightweight mode for a WLC to actually manage it. And a WLC, or wireless LAN controller, manages these access points using CAPWAP tunnels. You're going to have a control and a data CAPWAP tunnel. The control tunnel is going to be giving that wireless LAN controller its profile and settings and how it should interact, right, with its Wi-Fi enabled devices. And then it's going to have a data tunnel where it's actually sending those endpoints data back to the wireless LAN controller. So the wireless LAN controller can decide how to route that traffic or switch that traffic, okay? So we're going to get into wireless LAN controllers later on in the series as well. If you'll look right here, you can see I actually have a wireless LAN controller here that I'm going to configure for you in this course. So you guys can actually see it real world. Some of other training courses, they'll use like Cisco Packet Tracer to try to emulate this, or GNS3. I decided to give you the real thing because of how buggy it can be. And on the exam, wireless is kind of a big section. And it can be very specific in what they're asking. So I have that. And then three of these access points. This is a AeroNet 3700 series. So we can definitely have some fun going over wireless in this series. All right, let me clear this up. And then we have SDN. This is one of my favorite things to talk about because it is the future. It's actually the present. But SDN, software-defined networking and controllers, we're going to go over as in-depth as we should for the CCNA exam. So this is called controller-based networking, okay? It says relatively new concept, but it's really not. Even when I started doing IT back in 2014, this was already being talked about and implemented in some environments and with other vendors like Juniper, which we don't talk about, right? Because it's a Cisco course. So a controller in networking is a central place of management to control and manage all your control plane traffic from a centralized point. So what do we mean by that? All the features and protocols that are used on our network devices to dictate the flow of traffic, we call that the control plane. And in traditional networking, if we have a switch here, let me change up my colors. You'd have two planes on that switch. Not going to get into the management plane. You'd have two planes. You have the data plane that actually does like on the wire packet forwarding, right? So that's literally like the electrical signals in the data plane helping forward that traffic. Then you have the control plane, which is all of our routing protocols, all of our switching protocols, OSPF, CDP, Cisco Discovery, STP, everything that pretty much was the brains of that networking device. These control and data planes were all in one on that device. So that means it took an administrator to go to each individual device to configure that control plane and make sure that every device was talking on their control planes to forward traffic correctly. Well, with controller-based networking, we kind of flipped the script where the only thing that device is now going to have is a data plane because, it still needs to forward traffic on that wire, right? And then the control plane is going to go to a centralized controller that's going to be connected to all these southbound infrastructure or the underlay infrastructure. So routers, switches, access points, right? And it's going to control and give policy and have a central managed point, okay? So that's what controller-based networking is. And some of the flavors for Cisco is going to be Cisco DNA Center, which again is SD Access, right? And then Cisco SD-WAN, which Cisco SD Access is more for the LAN and your campus networks, controlling switches, security policies on that LAN, right? Integrating identity service engines into there. You can see DNA Center controlling Cisco Meraki infrastructure. Whereas SD-WAN is going to be more on that transport side. So how are we transmitting packets across a WAN, right, across the internet? That's going to be more of SD-WAN. And we're going to get into those as well. Unfortunately for the CCNA, you don't get into much configuration of SD-WAN or DNA Center SD access, but we will go over it. I will try to show you an SD-WAN infrastructure in EVE-NG just to kind of get you, get the feels about it. And then the last thing we're going to go over, and this will be the shortest thing we go over, is an endpoint. We all know what an endpoint is. An endpoint is a device that is connected to your network that you use to access network resources, right? So an endpoint, printer, computer, laptop, phone, VoIP system, right? Anything that the user interfaces with to connect to network resources and communicate, okay? Those are what endpoints are according to the CCNA exam. And they even consider servers to be an endpoint, which they are, right? Because it's still, that machine is just there for connections, right? It's not involved in the routing and switching of traffic. So a server is connected to our network infrastructure to service all the endpoints, right? So yeah, that's what endpoints are in the CCNA. All right, awesome. So my camera just decided to die on me, so that's a good thing we're ending the video. So I want to thank you guys for viewing, and stay tuned for our next videos.